Okay, let's talk through some synthetic division examples. So let's look at it. It's so much easier than long division. You're going to love it. First one, I want to divide 2x squared minus 3x minus 5 by x plus 1. So what I'm going to do is I'm going to make my synthetic substitution, or now we're going to call it synthetic division diagram. This little box and a line. And then I'm going to look at my coefficients. I'm going to make sure that I have my exponents are going in descending order with no holes. So I'm starting with x squared, then x to the first, then x to the 0. So I'm good there. So I'm going to fill in my coefficients. -5, and then I am going to look at this binomial right here. And I'm going to say that what I want to put in this box is the value of x that makes this binomial equal 0. So that makes this guy equal 0. Okay? And that value right here is -1. Okay? So you are putting in the 0, the value of x that makes it equal 0. That's very important. If you have the wrong sign, then all your division will be wrong. Okay? Once you're here, now we can just roll. It's a very quick process. You bring down the first number, you multiply this and this. -1 times 2 is -2. And then you add up your columns. -3 plus -2 is -5. -1 times -5 is +5. -5 plus 5 is 0. Okay? This right here is your remainder. And these are the coefficients of your quotient. Now, look at the original problem. We divided a quadratic by a linear. So if you take a quadratic and divide it by a linear, you should end up having a linear quotient. So that means that the degree of your quotient will be 1. So this is going to be 2x minus 5. All right, and with no remainder, then this is just your quotient right here. All right, let's look at another example. I want to divide p of x by x plus 2. So I'm going to make my synthetic substitution picture, synthetic division picture. I'm going to look at my exponents 3, 2, 1, 0. I'm good. So those guys are fine. I'm going to put my coefficients down. If you don't see a number, then remember that that number is 1. So 1, 5, 5, -2. And then I'm going to say to myself, what value of x makes that 0? And that's -2. So now I'm going to bring down my 1. I'm going to multiply and add. -2 times 1 is -2. If I add up that column, I get 3. -2 times 3 is -6. When I add, I get -1. -2 times -1 is 2. When I add, I get 0. Okay, this time I'm dividing a cubic function, right, by a linear function that has a degree of 1. So let's say x cubed divided by x to the first. That means my answer is going to have to be a quadratic. So I have 1x squared plus 3x minus 1. These numbers become the coefficients of my quotient, and then remainder 0. So I don't have to put a remainder at all if I don't want to. All right. And that is the solution to that example.